Good morning everyone, thank you the opportunity. Here I will presentation material about vector. Okay, before I presentation introducing myself. My name is Putri Cornelia, nickname 201302111. I'm from class 3A Physics Education. Next, discussion point number 1, coordinate system. Number 2, vector and scalar quantities. Number 3, some properties of vector. Number 4, component of a vector and unit vectors. Next, material 1, coordinate system. The mathematical description of an object mentioned requires a method for describing the object position at various times into dimension. This description is completed with the use of the Cartesian coordinate system, in which perpendicular axes intersect at a point defined as the origin. Figure 3.1. Cartesian coordinates are also called rectangular coordinates. Next, sometimes it is more convenient to represent a point in a plane by its plane polar coordinate r, theta, as shown in active figure 3.2a. In this polar coordinate system, r is the distance from the origin to the point having Cartesian coordinate x, y, and is the angle between a fixed axis and a line drawn from the origin to the point. The fixed axis is often the positive x-axis, and theta is usually measured counterclockwise from the right triangle. In active figure 3 2b, we find that sin theta y defined by r and that cos theta x defined by r. A review of the trigonometric function is given in appendix B4. Therefore, starting with the plane polar coordinate of any point, we can obtain the Cartesian coordinate by using the equation x equal r cos theta and y equal r sin theta. Furthermore, if we know the Cartesian coordinates, the definition of trigonometry tells us that tan theta equal y defined by x, r equal akar x quadrat plus y quadrat. Next, material 2, vector and scalar quantities. The difference between scalar quantities and vector quantities. When you want to know the temperature outside so that you will know how to dress, the only information you need is a number and the unit degrees C or degrees F. Temperature is therefore an example of a scalar quantity. A scalar quantity is completely specified by a single value with a portrait unit and has no direction. Next, other example of scalar quantities are volume, mass, speed, and time intervals. Some scalar are always positive, such as mass and speed. Others, such as temperature, can have either positive or negative value. The rules of ordinary arithmetic are used to manipulate scalar quantities. If you are preparing to plot a small plane and need to know the wind velocity, you must know but the speed of the wind and its direction, because direction is important for its complete speed specification. Velocity is a vector quantity. A vector quantity is completely specified by a number with appropriate unit plus direction. Next, material 3, some properties of vectors. Next, equality of two vectors. For many purposes, the vector A and vector B may be defined to be equal if they have the same magnitude and if they point in the same direction. That is, vector A equal vector B only if A equal B and if a vector A and vector B point in the same direction along parallel lines. For example, all the vectors in figure 3.5 are equal even though they have different starting point. First, When two vectors are added, the sum is independent of the order of the addition. This property, which can be seen from the geometric construction in figure 3a, is known as the commutative law of addition. Vector A plus vector B equal vector B plus vector A. Next, material negative of a vector. The negative of the vector A is defined as the vector that when added to gives 0 for the vector sum, that is vector A plus buka kurung minus vector A tutup kurung 0 equal 0. The vectors A and min A have the same magnitude but point in opposite direction. Next, material subtraction vectors. The operation of vector subtraction makes a use of the definition of the negative of a vector. We define the operation A minus B as vector min B added to vector min A equal vector A minus vector B equal vector A plus buka kurung minus vector B tutup kurung. Next, material multiplying a vector by a scalar. If vector A is multiplied by a positive scalar quantity M, the product MA is a vector that has the same direction as A and magnitude MA. If vector A is multiplied by a negative scalar quantity M, and then the product min MA is directed opposite. Okay, next, material for components of a vector and unit vectors. The graphical method of adding vectors is not recommended whenever high accuracy is required or in three-dimensional problems. In this section, we describe a method of adding vectors that makes use of the projection of vectors along coordinate axis. These projections are called the components of the vector or its rectangular components. Any vector can be completely described by its components. Okay, next, unit vectors. Vector quantities often are expressed in terms of unit vectors. A unit vector is a dimensionless vector having a magnitude of exactly one unit. Vectors are used to specify a given direction and have no other physical significant change. They are used solely as a bookkeeping convention in describing direction space. We shall use the symbols E, G, and K to represent unit vectors pointing in the positive X, Y, and Z directions respectively. The heads or circumflexes on the symbols are a standard notation for unit vectors. The unit vectors E, J, and K form a set of mutually perpendicular vectors in a right-handed coordinate system. The magnitude of each unit vectors equal 1, that is multa J Jacobi equal multa E Jacobi, mutual multa J Jacobi, and equal multa K Jacobi equal 1. So many presentation for me. Thank you.